All right, let's get quiet, focus. All right, any issues on graphing those problems yesterday? Just put in your calculator, right? What about issues finding the horizontal and vertical asymptotes? Any problems with that?
No, good.
Okay. Domain and range is everything but whatever the vertical and horizontal asymptotes are, right? Jordan? 24 and 27? Okay. All right, so we talked about just putting in our calculator, right? Yeah, you did, Caleb. So why did you do that?
Who did that?
All right. So go to your y equals to put it in your calculator. And remember, put these in parentheses. When you put it in your calculator. Okay, so if you didn't put them in parentheses, you might have got some stuff that looked weird. All right, so parenthesis 8x plus 3 divided by parenthesis 2x minus 6. Now, before I graph this, let's go over what the asymptotes are. Okay, what makes the bottom 0? 3, right? Add 6 and divide by 2, right? Right, Collins?
Yeah.
So the horizontal, that's not horizontal. That's your vertical asymptote, is what makes the denominator 0. So that's x equals 3. Okay, if I asked you what the domain was, you'd say all values of x except 3, right? You're right, x does not equal 3 for the domain. You with me on that? Horizontal asymptote Horizontal asymptote is those two numbers divided. What's 8 divided by 2? 4. Oops, not 3. 4, all right? And then my range would be y is not equal to 4. Okay? That makes sense? That's what we talked about yesterday, right? Okay, now we're just going to graph it on our calculator. Hit graph. And there's our two branches. Okay? Jordan, did yours look like that? With two branches?
I think I just forgot to put it in.
Okay. Yeah, it'll look different if you don't put the parentheses. Okay? And if I drew in my asymptotes, where's x equals 3? 1, 2, 3. The red one. There's the vertical. Okay? And then y equals 4. 1, 2, 3, 4. The green one. There's 4. So there's our two asymptotes. Okay? So that's a pretty easy assignment, wasn't it? Calculator does the work for us. We do have to understand where we get our horizontal and vertical asymptotes from. Okay? Any other questions? All right. Today, we're going to simplify these rational expressions, these fractions. Okay? A rational expression is a fraction whose numerator and denominator are non-zero polynomials. The domain of a rational expression excludes values that make the denominator 0. It's in simplest form when its numerator and denominator have no common factors other than plus or minus 1. Okay? So this one, these both had a common factor of c, so the c's cancel, and we got a over b. Okay? 15 has a common, and 65 have common factors of 5. 3 times 5 is 15. 13 times 5 is 65. So the 5's canceled. So that reduces to 3/13. This polynomial had a 4 that was common to the top. So we factored out the 4 and had an x plus 3. The bottom was a trinomial that you could factor into x plus 3 times x plus 3. So the whole factor, x plus 3, can cancel. So this answer would be 4 is greater than x plus 3. Now, what is x not allowed to equal in that answer?
0.
Wrong.
1.
Wrong.
2.
3. No, not even 3. Negative 3. Right? We call those restrictions. Okay? Restrictions on the domain or the variable. X cannot be negative 3 there, or we get a 0 in the denominator. Okay? If I put 0 in for x, it's okay, because I get 3 in the denominator, right? But if I put negative 3 in the denominator, then I get 0. Or negative 3 in for x, sorry. All right? All right, so that's what we're going to do. We're going to take out common factors and cancel them. Some of our common factors will be numbers. Some of our common factors will be x plus 3s and x minus 2s and x's and that kind of stuff, y's, that kind of stuff. All right, so before I can simplify this, I have to factor both the numerator and the denominator. So, Caitlin, what's the top the numerator factor into? What are the factors of what times what equals negative 12, but when you add them, you get negative 4?
Negative 6 and 2.
Good. So negative 6 times positive 2 is negative 12. And when I add negative 6 plus 2, I get negative 4. And again, to get x squared, it's just x and x. Okay? So we haven't factored for a while, but that's nothing new to us, right? Now these only have 2 terms, but they're both perfect squares with a minus between them. We call that a difference of squares. So Mr. Collins, what are those factor into? X and 2, right? Square root of x squared is x. Right. Square root of 4 is 2. One's plus and one's minus. So now that we have it factored, do we see any common factors? One in the top, one in the bottom. Those x plus 2's, right? So again, they have to be one in the numerator and denominator to cancel them. If they're both in the top or both in the bottom and they're the same, you can't cancel them. Got to be one up top, one in the bottom. All right? So our answer then, simplified, is x minus 6 over x minus 2. Okay? And what is x not allowed to be? Negative 2 there and positive 2 there, right? Those are our restrictions. It's the original problem that we look at to see what our restrictions are. What? Or you can put plus or minus 2 if you want, instead of writing 2 twice. Does that example make sense? You got to factor first. Don't just start canceling. I'll see kids always see an x squared, and then cancel. No. If it's all multiplication, yes, I could do that. If this was all multiplication, no subtraction, I could cancel that stuff, the 4's and the x squareds and stuff. But if there's pluses and minuses, I have to factor it first, like we did, and then cancel.
So would it be like, you would take the top x plus 3 and the x minus 3 and get the 3?
Yes. What makes those zeros? Yeah. That's what x is not allowed. Just the bottom, yeah. You can have 0 in the top. You can't have 0 in the bottom. So we call those, again, restrictions on our variable or domain. All right. So again, we have some minuses up here. So I can't just cancel stuff. I have to factor first. Okay, you can only cancel factors. All right, so what are the factors of -3 that add up to -2? -3 and a +1, right? Oops, +1. All right, what about the bottom? Factors of -6 that add up to -1. -3 and +2. Is that what you said, AJ? Good. Any common factors? The x minus 3's, right? So the x minus 3's cancel. So my answer is x plus 1 over x plus 2. And what's x not allowed to be? +3 and -2. It's not too bad, is it? Not there yet. I know you love to do homework. Okay. What about this top one here? What do we have to factor out there? I heard somebody say it. 2, yeah. GCF, right? Always look for a GCF, right, Emma? So when I take the 2 out, what's left, Sydney? When I take the 2 out of there, what's left? X 1, good. X plus 1. All right. What about the bottom one, Taylor? The x and x, right? Then what? What are factors of 3 that add up to 4? 1 and 3. Now, since everything's positive, it's just +1 and +3. You don't have to have one of each. When it's negative, you do. Okay, if this was a -4 there and +3, those would both be -1s. Okay? Do we see common factors? Right, so that x plus 1's cancel. So what's the top answer? 2. What's the bottom? X plus 3. What's x not allowed to be? -1, -3. Making sense? You guys are doing really well so far. Any questions? No, not yet. We're going to multiply also. Okay? All right, we're going to multiply. When you multiply fractions, you just multiply straight across the top and the bottom. Okay? But, so what they did here is they went 5 times 6, get 30. X squared times x was x cubed. And then there's the y cubed. And then 2 times 10 was 20. X, 1x, and then y squared and a y is a y cubed. Okay? So what they did then is they factored 30 into 10 times 3 and 20 into 10 times 2. And then the 10's cancel. See that? And then they factored x cubed into x times x squared. So the x's cancel. And then both had a y cubed, top and bottom. So the top was a 3 and an x squared, and the bottom was a 2. And then x and y are not allowed to be 0. Okay? You didn't have to do, well, they kind of factored it, but you don't really have to factor it. Here's how I would do it. I wouldn't even multiply. I would just look at this. Okay? And I'd say to myself, how many times does 5 go into 5? Once. How many times 5 go into 10? 2 times. And then I look at the 2. How many times does 2 go into 2? Once. How many times does 2 go into 6? 3. Okay? So there's my 3, there's my 2. Okay? Now I look at the x's. How many x's are up top? 3. How many in the bottom? 1, right? So I'm thinking this. So what's the rule? Where's the higher exponent? top, so x stays up top. And then what's 3 minus 1? 2. And then I see 3y's up top, 3y's in the bottom, so they all just cancel out. So there's no more y in the problem. Does that make sense? So I don't waste time multiplying it all out. But if you'd rather multiply them together and then do that, that's fine. Okay, again, we did not really have to factor, okay? So I'm looking at 8 and I see a 2 and a 4. So what happens to this 2 and this 4 and that 8? They all cancel, right? You see that? 2 times 4 in the bottom is 8, and there's 8 in the top, so they're canceled. I didn't have to factor because it's all multiplication. You don't see any addition or subtraction, do you? All right, now how many x's do you see up top? 7. How many x's in the bottom? 1. So that means how many are up top? 6 of them. The only other number I see is that 7, so that stays up top. 2 times 4 is 8. So the 8 in the top and 8 in the bottom cancel each other out. Makes it a 1.
Okay.
There's 7 x's up top, Sydney, and there's 1 here. So that 1 in the bottom takes 1 away from 1 in the 1 in the top. So there's only 6 x's left. Okay? There's 7 up top, there's 1 in the bottom. So there's 6 total left in the top. Look at the y's. How many are up top? 4 y's up top. How many y's in the bottom? 3. So where's the y going to stay? Top. How many are going to stay up top? 1. Yeah. Anything left in the bottom? No. I can put a 1 if you want, but if nothing's left, you can just leave it as 7x to the 6th y. So these are a little bit easier because you don't have to do any factoring. Does that make sense? Okay.
Oh my God. I don't think we're gonna get through every example, honestly. It's good at F.
All right. So what can I factor out in the top left? 3 and x, right? What's 3x divided by 3x? 1. What's negative 3x squared divided by 3x? Negative x, right? What are the factors of negative 5 that add up to 4? Positive 5 and a negative 1, right? 3x, we can't factor that. What are the factors of negative 20 that add up to 1? Those, right? 5 times negative 4 is negative 25 plus negative 4 is 1. Do you see any common factors? X plus 5s can cancel, right? Anything else? The 3x's. Are these the same? No, those are not the same, are they? They have to be exactly the same. Okay? All right. If I factor out a negative 1, would they be the same? If I take out a negative 1, it'd be negative 1 plus x, wouldn't it? Is negative 1 plus x and x minus 1 the same? Is the x positive and 1 negative for both? Yeah, so if you see opposites like this, take a negative 1 out of one of them, and they'll cancel. So what's up top? A negative 1 and an x minus 4. And what's left in the bottom? Nothing. You can put a 1 if you want, but you don't have to. Okay? If they don't ask us to write the restrictions, then we're not going to worry about it. Sometimes they'll ask us in the directions. All right? Questions? So sometimes you'll get opposites, like we did here, with that 1 minus x and x minus 1. Factor out a negative 1 from one of them, and then they'll be the same. Okay?
Really want.
Do you understand what we're doing?
Not the last. That's enough time unanimous. The rest of them are okay. That certainly did not sound good. He doesn't.
All right, we won't do C.
And you'll get tears tonight.
That one, do we have to worry about factoring?
No.
No, we don't have to worry about factoring there, right? That's like the other one we did. Here we'd have to factor, right? So, like I said, we're gonna have a short period, so there's your homework.
Easy stuff. Yeah.